All right, so here we have an example to do right triangle trig. We have our right angle down here. We have the angle we want that we're working with up in that top right corner. And now we have to try and put it, let's find the tangent of theta. Okay, that's what we want to find, tangent theta. Okay, we could put all 6 of them together, but it's going to be really nice. So for tangent is opposite over adjacent. This is my opposite side, because it's across the triangle from the angle, and the 3 is my adjacent side. So the good news is I have the 3. The bad news is I don't have a number here. Uh-oh, that's going to be problematic, except it's not, because we have that wonderful thing called the Pythagorean theorem, which says a squared plus b squared is equal to c squared. Please keep in mind the hypotenuse is always c. A and b, interchangeable, don't matter. But the hypotenuse has to be c. Otherwise, it's not going to work. So I need to find this side. So let's call this a. So we know that a squared plus 3 squared has to equal 10 squared. So that's a squared plus 9 is equal to 100. I'm just plugging in the numbers. I'm going to subtract 9. A is equal to 91. Oh, sorry, a squared is 91. Which makes a the really revolting square root of 91. Okay, so we have our square root, and unfortunately that's what my side is here. It's the square root of 91. But now I can build the tangent. Tangent is just going to be the opposite over the adjacent. So it's going to be square root of 91 over 3. And that's the tangent of theta. Done. That was fun. Now, if I want the cotangent, because this would be a good one to look at here, the cotangent is just that reciprocal. But here's the thing, if I flip this over, now I have that square root in the denominator. We don't like having the square root in the denominator, so we're going to rationalize it. We multiply the top and the bottom by that square root. And we end up with 3 square root of 91 over 91. And that's how we're going to do this. And then I want to do one more problem here, but I need to clear off my board. All right, so here's our next example. This time I have a trig function. I have its value. Tangent of theta is 5 over 6. And I want to find cosine. We don't have a triangle. That's okay, we're going to make one. That's all we're going to have to do here. What we need to remember is that tangent is opposite over adjacent. And so if we build a right triangle and we label an angle theta, by the way, it doesn't matter if your triangle is to scale, we know that tangent is going to be 5 and 6 opposite over adjacent, right? This is my opposite side here because it's across from the angle I'm working with, and the 6 here is the adjacent side. Well, if I want cosine, I just need the hypotenuse. So basically, this is exactly like the last problem we did. We just had to build the triangle first. And so this time I'm looking for c, right? I'm missing the hypotenuse. So 5 squared plus 6 squared is equal to c squared. 25 and 36 is c squared, that's 61. We end up with a square root of 61 for c. Again, we get a pretty gross looking number, but now we can put together the cosine. Cosine is the right, adjacent over hypotenuse. So I'm going to have 6 over the square root of 61. And when you rationalize that denominator, you're going to have 6 square roots of 61 over 61. So loads of fun. Loads and loads and loads of fun. I was wrong, though. I do want one more problem. So here we go. All right, really the last example. All right, here's what we have. This time I have a triangle, and notice that I actually have a value for my angle. So I have an angle here, 40 degrees, and I have one side of the triangle. We could find, and I'm trying to find this other side of the triangle. We could also try and find the hypotenuse, but honestly, if we have these two sides, then we can just use the Pythagorean theorem. So here's how I want to go about doing this. And I already wrote it out here for you so you can see it. But I need to pick the trig function that connects this angle to those two sides. And so when I look at this, for this angle, x is my opposite side and 20 is the adjacent side. That should scream at you tangent. Okay, tangent is opposite over adjacent. Now, could you use cotangent? Yes, but it's not a button on your calculator. So let's use tangent instead. So the tangent of 40 degrees has to be equal to that ratio, x over 20. I'm going to multiply both sides by 20. That's how I get the 20 here. And then I'm just going to type it into my calculator. be careful. So we've talked about this before. You need to be in the right mode. You have to be in degrees in this case because our angle is in degrees. If you're in radians here, which I was when I typed it in my calculator, you actually get a negative answer, and which should be a really big tip-off. That didn't work out right. This should probably be a positive value. So anyway, put it in. You make sure you're using degrees, and if you do, you get 16.8. And that pretty well sums up right triangle trigonometry. Now, are you going to run into stuff on the homework that's going to be trickier? Absolutely, and we'll have fun answering those questions. Thanks.